Right, this is a worked example for an exponential model. People infected with a disease. This is in the modeling section. Now, this is fairly nice, simple problem. I mean, most of these modeling problems, you basically have to identify the sort of general form and apply boundary conditions to work out the actual particular form of the relationship. We don't have to do that with this one. This is all done for us, and it's given. The relationship is given to us here. Let's have a look. The number of people infected with a disease is modeled by the formula n equals 300 minus 100, and that is e to the power of minus 0.5 t. Okay, I'm just going to write that down there. Equals 300 minus 100 e to the power of minus 0.5 t. Okay, so what's going on here? Well, we can see that as t increases, this e to the power of minus 0.5t is going to get smaller and smaller and smaller. This number, so this term here will get smaller and smaller and smaller. So it's all going to tend to 300. Likewise, when t is equal to 0, this term is this factor here is 1, and therefore we've got 300 minus 100. Okay, so that's what we're looking at. The questions are, how many people were first diagnosed with the disease? Well, that is just that, and t equals 0. What we've got is n equals 300 minus 100 times 1 e to the power of 0. So that's 200. So the number of first diagnosed is 200. What is the long-term prediction of how this disease will spread? Well, as we've said, as t gets bigger and bigger, this gets smaller and smaller. So this whole thing here tends to 0. So this will sort of asymptote towards 300. 300 is going to be the sort of the limits, the number of people infected. Okay, so that's A and B, and then it says sketch the graph of n against t for t greater than 0. So here we go. So it starts off at 200, and then basically this is a kind of inverse exponential effect here, and we're plateauing off and asymptoting towards 300. Now, this is a model, of course. Models don't have to be absolutely accurate. They just have to be useful for any predictive purposes that we want to put them to. So it might well say that, we want to know what how many people are going to be infected after 10 years or something like that. So that's what we're looking for. So that is it, short and sweet. I think it just helps to kind of illustrate the nature of these, well, certainly these exponential models. And yeah, half the job's been done for us on this one as well. All right, well, thanks for listening.